All right, so we have an altitude drawn. From the right angle to the hypotenuse. All right, so that condition, that initial condition must be true before we can do anything else. All right, if it's not, then we have to come up with a whole nother plan. All right, so what we do have here is we do have a hypotenuse, a altitude being drawn to my hypotenuse, right? So everybody can agree that that is what we have. We have an altitude drawn, and it is being drawn to my whole hypotenuse. Now, if I wanted to find the measurement of my whole hypotenuse, I just need to add the two parts together, which is, 7 plus 9, which equals 16. All right. So that's so far, that's what we've got. Now, we know that inside of a triangle, particularly a right triangle, that we have two legs and a hypotenuse, right? So we have this leg. Ooh, do it again. There we go. So we got the leg and another leg. Now, what my altitude does when it drops from my right angle down to my hypotenuse, it cuts my hypotenuse into proportional parts. Okay, so we end up with a part 1 and a part 2 of my hypotenuse. All right, so all of these are going to be proportional. All right, so our first case, which we'll call case 1, is going to be my altitude as geometric mean. In other words, he's going to have my dual position. You got to remember that in a proportion, we have 4 parts, right? We have 4 positions in our proportion. So if I were to draw out a proportion, I've got 4 spots that need to be filled, right? And usually we're solving for one of them, or in this case, 2 of them possibly. All right. So that means that my altitude is going to be in my duplicated position. In other words, it's going to be in one of my extremes or means. And that is going to be to my part and our part. So again, altitude is the geometric mean to the parts. All right. Just commenting? I figure usually y'all are talking to somebody on the phone. Yeah, this is Monday's part, I think. Yeah, Mondays. That's when I start questioning myself, like which day did I do? Because I've done this one now for 3 days. All right. All right. So now taking what we know and plugging it in. X is my geometric mean, so it goes in my double. And 7 and 9 are my other 2 parts. Cross multiply. And of course, y'all guys know me. I'm going to try and simplify my radical first. So if I take these square, ooh, that's too big. There we go. Square root. What's the square root of 7? Can we take the square root of 7? It's ugly, isn't it? It's pretty ugly. What's the square root of 9? 3. So that is my simplified form. So I can get more math if it asks you for the exact, that's what it's looking for. Okay. Otherwise, all you have to do is just type it into the calculator, which would have been the square root of 63. You get 7.94. All right. All right, so now that is finding x. So that was our altitude. Now, what we want to do is we're going to go ahead and find our other two legs, and that's going to be our case 2. Case 2 is this time the leg is the geometric mean. So that he's going to be in the dual position this time instead of my altitude. But again, what's going to happen is that we're, instead of being two part, it's going to be the closest part, so part closest to the whole hypotenuse. Okay, so this time again, it's going to be one of my parts and then my hypotenuse. Okay, now there's two legs, so we have two proportions to set up, but they're essentially going to be the same type of pattern, just different numbers depending on which one we're looking at. All right, so for our first one, we're going to look at y, and the closest part is 7. So y is going to go into my dual position, and it's going to be 7 to my whole 16. Okay. And again, cross multiply. And again, I'm going to take the square root. And again, like I asked earlier, can I take the square root of 7? No, it's ugly, right? Can I take the square root of 16? So 4 square root 7 this time. And so 10.58. Okay, so far. Now, of course, if you would have done, let's see, whoops. Square root, 7 times the 16. We would have gotten the same thing. All right, so I don't know what 7 times 16 is. Too big a number for me to try and float around in my head. All right. So, all right, so that gives us y. Now we need to do it one more time, and this time we're going to do it for the other leg. So this time we're going to be looking at this leg and his part, which is over here on the other side. All right, so this time it's going to be z is my duplicated position. My part closest this time is 9 instead of the other. Okay, so it's the closest part to that one, but it's still to my whole hypotenuse. Fair enough? Okay, so again, kind of see the difference between, we had 7 over here and then we have 9 over here. All right, so it's whatever part is closest to my value that I'm looking for. Cross multiply. So z squared is going to equal 9 times 16. We're again taking the square root all the way across here. And that's going to give me z. And of course, this time the square root of 9 is, and the square root of 16. And that equals 12. Can you see why I don't like to use the calculator? The decimal values are no fun. Okay. I just find that working with my square roots and carrying them around is a little more compact. It's like driving a smart car. You know what I mean? It's just like everything's real small, compact, and I just can carry it around, and you could actually go and pick it up and carry it, like literally pick it up and carry it. I'm not joking when I say that you can literally pick up a smart car and carry it. Have you seen people do that? Where they pick up a smart car and like turn it sideways so it can't get out of the parking spot? They're that light. You can actually like 3-4 guys can pick it up and just turn them. Fiats are also the same way. They're real small. Okay, so just think about square roots. They're just that long decimal that's like stupid ridiculous, and it's compacted into this little bitty square root. Okay, so it's a number that's all nice and little